We have hormones, of course, produced by gonads, so ovaries and testes. When we look at the production of these hormones, they are steroid-based. So these are lipid-based, fat-based hormones involved in growth and development and, of course, reproductive cycles and sexual behavior. So if we look at testosterone and estrogen, and there are a few others, progesterone, things like that, we look at these high levels of production associated with primarily females for estrogen. The progestins or the progesterone are typically associated with the females again, with the uterus and the development of the embryo. And the androgens, the main one you know, associated probably is testosterone, associated with males and the male reproductive system development and maintenance. That does not mean that females don't produce testosterone. They do, just in much lower levels. And it doesn't mean that the males don't produce estrogen. They do, just in much smaller levels. So this balancing act of hormones is critical, and it is, again, as you probably could figure out, regulated by the hypothalamus and the pituitary gland. We have the hormone that we mentioned in particular is prolactin, stimulated release by the hypothalamus from the anterior pituitary. And we're looking here for prolactin to actually stimulate the mammary glands to grow and produce milk during pregnancy. And we know that high prolactin levels will actually inhibit ovulation for females. So we look at the role, we've looked for years at the role of prolactin associated with childbirth and nursing and care of young. But recently, we've started to look at prolactin as an ancient or highly conserved hormone that we find in many, many animals, not just humans. So this is fascinating, that this hormone would be found in all these animals that are not mammals. They don't have mammary glands, okay? So non-human mammals will actually look at the association with fat metabolism and reproduction. Well, that's not so far off, right? Well, what about birds? Birds and non-human mammals, they found that prolactin is actually associated with nest building. Increased levels of prolactin will cause the organisms to build a nest. That's bizarre. In amphibians, it gets even weirder. Prolactin actually stimulates the movement to water. Well, where do amphibians reproduce? In the water, right? So this prolactin is still associated with reproduction, but its direct effect makes the organism go back to the ponds where they might reproduce. Migrating fish that actually migrate from the sea or salt water to fresh water, in these, we actually see prolactin, so increased prolactin levels actually increases their homeostasis of water and salt balance, which has absolutely nothing to do with reproduction, right? Except that many of these organisms that move from salt to freshwater go back to the freshwater to reproduce. So the prolactin is actually helping them deal with the fact that they're no longer in a salted environment. Bizarre, but fun. Evolutionarily, this is an amazing hormone. Can you take these 8 hormones at the top, match them to where they're actually produced, and match them to the effect they would have? We've talked about all of these.